Okay, so today we'll be talking about the ETAP 14 Arc Flash analysis module. What I'd like to cover today is the new Arc Flash features in ETAP 14. We're going to go over the Arc Flash interface enhancements. We're going to talk about the updated standards in ETAP 14. We're going to talk a little bit about the background behind calculation enhancements and new calculation features as well. So the first thing I'd like to bring up is the new interface features in ETAP 14. The first thing you will notice when you launch ETAP 14 is that Arc Flash now has its own independent study mode. So Arc Flash is no longer nested under short circuit analysis. Arc Flash now has its own independent study mode, and the advantage of having Arc Flash have its own independent study mode is that you're now able to be more productive, you're able to be more efficient on performing an Arc Flash analysis. You're now able to create a TCC right from the Arc Flash study mode. Here, let me go ahead and bring up a copy of ETAP 14 for everyone to see. There's a short circuit analysis mode. So for those of you who have used or performed a short circuit analysis in ETAP, you have your toolbar over on the right hand side. There's your three-phase device duty, single phase device duty. We now have also the Arc Flash analysis mode right here. For the Arc Flash analysis mode, you notice that you are now able to create a TCC, right? You have the TCC button over on the right hand side. So if I want to select this main and load breaker here and create a TCC, I no longer have to switch to the start mode. I can do everything from within the Arc Flash analysis mode. Another enhancement to the interface has been the ability to now you have a new scenario wizard with just Arc Flash only options, right? And then you've got your own study case also. So when you click on your study case, you now have options that are related just to Arc Flash, which that's powerful because now you could have a study case, right? You open up your briefcase here, you could have a set of options that are conservative just for Arc Flash. And when you switch over to short circuit analysis mode, you now have your original short circuit study case options, which would be conservative for performing device duty evaluation. Okay, so that's the that's kind of what I wanted to cover in regards to the new interface. In regards to updated standards, the updated standards that are part of this release are the 1584, IEEE 1584, the NFPA 70E 2015, for Canadian users, the Z462 standard, and also the standard specifications for rubber insulating gloves. For the Arc Flash guidelines, the IEEE 1584 guidelines have been updated and built into ETAP 14 as they apply to main protected device isolation and load side arc fault. The NFPA 70E 2015, the new category is basically the new layout for the Arc Flash labels has been updated as per the NFPA 70E 2015. Also, new labeling requirements for Canadian Z462 guidelines that is built into the Arc Flash labels. Shock risk assessment, and also we'll talk about the new correction factors. By some of the new enhancements now allow you to put a line side and load side for your source protected device, as well as a line side and load side for your load protected device as you could see here on the presentation. So depending on how your switchgear lineup is laid out, right, you may have use for some of these new labeling enhancements. Okay, so let's briefly go over now the some of the new NFPA 70E 2015 enhancements and how they apply to ETAP. So label enhancements are now based on the new NFPA 70E 2015 is that the prohibited approach boundary has been removed from the label. Also, anything that used to say category 0, personal protective equipment, PPE, that has also been removed. Updated has been the shock risk assessment. It's now based on the NFPA 70E 2015. And also, the annex modifications or these guidelines that the NFPA 2015 provide under Annex H2 and H3, they have been built into the program. So the first thing I'd like to do is, for some of you who have used ETAP to perform an Arc Flash analysis, you may have seen the following warning the first time you run an Arc Flash. So I have a distribution system here. It's a small radial industrial system. And those buses that are highlighted, such as this sub 2A on the left, sub 3 on the right, those are my fault locations. So when I run an Arc Flash analysis, right, and I press on Run Arc Flash, you may have seen this in the past. Warning, PPE approval is required. Then you click OK. You still get the incident energy calculations printed on the one-line diagram. However, it is the reason why that warning appears is because the engineer performing the Arc Flash analysis is responsible for meeting or agreeing with a customer, right, the plant owner or the engineer who is in charge of the safety of the facility, so they can agree on a PPE matrix, right? What is the personal protection equipment limits and description should say. So that is the reason why ETAP gives you that warning to allow you to stop, right? Contact your end user, right? Or meet with the engineer in charge of safety and try to come up with a PPE limits, PPE description. In order to approve a personal protective equipment table, you simply open your study case, like I have done here in my briefcase, go over to parameters, and there is a field here under where you have incident energy levels and the standards that have been supported by ETAP. There is an edit approve PPE. This allows you to select the latest PPE table, which is the NFPA 70E 2012 to 2015. It also allows you to browse or pick older PPE tables. Moving forward, I think most of us would always, select the latest and greatest NFPA 70E PPE level. So when you select NFPA 70E 2012, the engineer performing the analysis as well as the plant owner are free to define, right, the limits and the description on the PPE table. That's why by default all of this is user definable. For those of you who would like to use the provided Annex H2 or H3B guidelines, ETAP has that built in. So under this pull-down menu called Personal Protective Equipment, we could specify Annex H3B NFPA 70E 2015 by selecting the annex and also selecting Reset. What you're doing is you're allowing ETAP to use that Annex H3B as our personal protective equipment table as the limits and the description that will be part of this project. So I'll go ahead and go with the Annex H3B. I'm going to approve my PPE. Now you notice that when once approved, everything becomes grayed out. The user is no longer able to modify the personal protective equipment. I'm going to click OK. So the next time I run Arc Flash, the warning now disappears. The reason why the PPE approval warning disappears now because it has been approved, right? I've communicated to the plant owner that this is the PPE that we're going to move forward with, and everyone is on the same page. So that's what I wanted to go over in terms of the new PPE. Now, moving forward with the presentation, you could see here a quick sample label. This is an example of a label as per the NFPA 70E 2015 requirements. All of the labels that you print from within ETAP now comply to this new deliverable. So again, the prohibited approach has been removed. You're no longer going to see a category 0 printed on the label. Some of the labels, like the one we have up here, will display the PPE requirements, a description similar to the yellow box that you see down here. It gives you a guideline on what should be worn by the person performing the work. Also, as per for those engineers who are doing arc flash analysis and are required to comply with the Z462 Canadian standard, the 2015 requirements for the label have also been updated as part of ETAP 14. And there is just a sample arc flash label displaying that. Okay, so what I'd like to go over now is additional interface features, some of the new enhancements that will make you more efficient when doing an arc flash analysis study. The first thing I want to go over is the ability to add marginal alerts. So just like in load flow analysis or when you're doing a short circuit device duty evaluation, ETAP now allows you to create marginal alerts. So for example, for this location here, sub 3, if I double click on this location and I go over to the Arc Flash tab, you'll find that under the alerts here, there is now an allowable energy. That's user definable. That's a limit that will ring up an alarm. So for example, I have allowable energy set to 6. When I run an arc flash analysis and I look at my alerts over on the right hand side, remember we are no longer in short circuit analysis mode. So all of the alerts are as how they pertain to arc flash. So looking at my alerts, I see that location sub 3 is now part of my critical alerts. The reason why is because my calculated incident energy of 7 calories is higher than the 6 calorie limit that I specified. So you could use these new marginal alert limits when you're doing maybe design work, or if you have very sensitive locations that you want to make sure that nobody works under over 8 calories, for example, right? Then you can go in, double click on the location, select Arc Flash, and put an allowable energy limit under the Alerts tab. Again, this will have no impact on your incident energy calculations. The only thing you're doing here is that you're creating an alarm, right? So if you have ETAP in your operator's room, before somebody goes out on the field, they need a quick verification on what the PPE should be. You run an arc flash analysis, and then you see that alert, right? Then perhaps you may need to go to a different switching configuration. All right. Now also the reports have been enhanced. So for those of you who create or customize Arc Flash report using the Arc Flash Result Analyzer, you now have the ability to add more information to those reports. Let me go over that. So again, looking at this or any location, I'm going to open sub 3 again. very basic. Under the info page, everyone is familiar with the info page. This is where you specify the name of the element, but most importantly, there is also an equipment tag number, an equipment name, and an equipment description. The text that you enter here typically helps you with maintenance logs. Maybe you want to track when the last maintenance was performed. Maybe you want to have the location, right? So for example, if you have specific under a substation, and within that substation you have different switchgear lineups, you could be very specific on what the location should be and the description, right? What is this particular bus or switchgear feeding? So all of this really has no impact on your study results, but it does have an impact on your report, meaning when somebody goes out and places all of these labels on the equipment, now they have a little bit more description, right, on what they should be looking for example. So all of this text that you specify here under the equipment name tag description can now be part of your overall Arc Flash report. And I'll show everyone how to do that. So what I did is I opened the location, I fill in the tag number, name, description, click OK. Right, you run your analysis, and then you open your Arc Flash result analyzer over on the right hand side. There's the Arc Flash analyzer. When you open the Arc Flash analyzer, we are displaying for every one of these locations, right, for all my locations that are being considered, bus 1, bus 2, actually the one that I was working on is sub 3, you now under the info input data, you now have, for example, a field that says equipment tag number. You have one that is called location. You have one that is called equipment name. So it is this column right here that you see right here. Right, this column now displays description, tag number, location, so that when you come and export this report into Excel, we're going to call this Arc Flash report 1, and when your Excel launches and you have your Arc Flash customized report within Arc Flash, you now, as part of your report, have a tag number or maybe a maintenance schedule number, right, or date, as well as a description. What is this location feeding, right? Where is this location located within my substation, for example? So those are the some of the new enhancements that I wanted to go over in terms of the report. Okay. Also, what I want to go over is, and here's a quick illustration, right, of those additional interface features. Okay. So you can make all of these part of the your Arc Flash report. Okay. Let me go ahead and close out of this. Okay, so we had a chance to go over the alert view. We had a chance to go over the Arc Flash analyzer. Again, when you open the report manager, right, you have I have only installed English labels. You still have the other options. This kind of depends on your IT and how the ETAP software is installed. But you have Portuguese, Spanish, you have, of course, English, Chinese, Korean, Russian, all of these languages for your Arc Flash labels. And all of the templates have been updated as per NFPA 70E 2015. Right, so just to go over the labels, the Arc Flash labels, the naming convention, because we get a lot of questions on the naming conventions. So when you look at your labels, the first numbers that you're gonna see would be your dimensions, right? So 3.5 inches by 7, right? 3 inches by 6, 4 by 4, 4 by 6, and then shortly after the dimensions, you have whether it is going to be a warning or a danger label. So, for example, on some of your labels. You may want to have danger if it's greater than 40 calories, or warning if it's under 40 calories. So that's what the next naming convention is specified. Also, if you don't see a warning or a danger, but you see the manufacturer of the template, a manufacturer for a printer, that template, for example, is for a Dura label, or that template is for a Brady label, or it's for an Avery, right? So there's also a number after it, or this would be the Z462. Those would be for the Canadian standard. Okay, so moving forward with the naming convention, after you look at the warning or danger of the manufacturer, you'll also see a number that is the template. So for example, for 3x6, you have danger 1, 2, 3, 4. Those are 4 different templates, just a different layout, a different way to express the Arc Flash label. And then you have a bus and a PD. So again, that is if you're going to be labeling the line side, right? If you're going to be exposed to the line side, or PD would be for the load, or your load side, or load breakers. Okay, so again, if you have any questions during this presentation, just let us know at the end. At the end, we're going to take 15-20 minutes just to go over everyone's questions. To print a 4x6 warning bus, I'm going to select PDF. When you select viewer, it just simply opens the crystal report, but it has been our experience that when selecting PDF, you're able to do 2 things. Number 1 is you're able to print your label or save it as PDF format right here. Number 2 is you get it ready for your printer, whether it's a Dura label, whether it's going to be a Brady printer, whether it's going to be your, just your standard inkjet with vinyl paper, or if you're going to be taking this to an office supply, maybe a Kinko's or an Office Depot, right? You send the PDF over to the print shop, or you bring it in with a flash drive, and then you ask them to laminate it, right? You ask them to print the label, to laminate it so it's weatherproof, and then you're ready to go out on the field and put them on the equipment. So the labels now have been updated to reflect the NFPA 70E 2015 standard. I'll go ahead and close my labels. And one of the other enhancements, very important, is the following. The calculation enhancements now allow some of the advanced users to perform different conductor orientation, handling of different orientations. So just a little bit of background on this. The configurations that are currently included in both the IEEE and NFPA 70E standards are the vertical conductors in a box. So just like the illustration that we have here, we have the vertical conductors in a box on the left-hand side, and then we also have the vertical conductors in open air. I'm sorry, that's on the left, and the in a box is on the right-hand side. So here's the vertical conductors in open air on the left. On the right-hand side is the vertical conductors in a box. So for most of us, right, maybe 80% of the locations that we label will probably be like the pictures, right, where you have your bus coming in vertically, and they could be in open air or they could be in a box. So both the 1584 equations provide correction factors for both of these instances. However, as an enhancement, right, with the help of correction factors, higher and lower or lower arc current and incident energies can be simulated within ETAP, right? And I say simulated because the factors are entered by the user, not by ETAP. and I'll go over how to enter the factors. So over on the left-hand side here, you have an illustration of a vertical electrodes cubic box terminated in a barrier. So there is a ETAP will provide you with a set of limits that you could use to simulate such condition, such configuration. In the middle, we have a horizontal in cubic box. So this is when you open up the switchgear, for example, and the bus bars would be directly pointing towards the worker's chest, right? The horizontal conductors. And over on the right-hand side, you have horizontal open air, all right? So all of these configurations are currently not handled officially on the NFPA 70E 2015 or the 1584, IEEE 1584 guidelines, equations. However, ETAP is able to provide the engineer the tool, right? ETAP is just providing the tool for you to handle the following configurations that can be applied within ETAP 14. Let me go over, for example, how to specify whether something is vertical, a conductor is vertical or horizontal, and what the conductor termination is. So I will come back to this, the presentation, but for example, for sub 3, let's say sub 3 was not your standard vertical in box configuration. Let's say when you open up this switch gear, the bus bars are pointing right at the worker's chest, right? They're horizontal. So for something like that, to specify the configuration, you open the location. So in this case, I open sub 3, and then you go over to rating. The rating tab is very important. Why? Because this is where you specify the type of equipment it is, right? Whether it's a switch gear, whether it's a panel board, it's open air. This will have a direct impact on your working distance, the working distance that's automatically selected from the IEEE 1584 typical values table. And just below the type, you have your Arc Flash parameters. So you have information such as the gap between conductors, which again is automatically updated when you select the equipment type. You have the distance factor, and most importantly, you also have the orientation. So for orientation, you have horizontal and vertical, right? Currently, only vertical is supported on the official IEEE equations. You also have conductor type, and you also have the termination, whether it's open tips or insulating barriers. So this is where you would specify your orientation. That's step number 1. So if I selected horizontal, click OK, run Arc Flash, notice there is no change on my incident energy because I said that's step number 1. Step number 2 is to enter a factor in the INI, the ETAP INI. Some of you may be familiar with the following location of these files. Some of you may not. So the incident energy and our current correction factors based on conductor orientation need to be entered onto the following file, the etap.s.ini. The entries are displayed with the default correction factors, right? The same as they're shown on the IEEE 1584. So I'm going to show everyone where that file is located, how you can access that file, and how you can go in and change what the correction factor is for the orientation. So going over to the Tools pull-down menu, I'm going to select Options, Preferences, okay? And then on your Options, Preferences, this is where you have a lot of Arc Flash options, load flow options, display options, one-line diagram options. Well, one of the shortcuts here is called Edit Current etap.s.ini. This is the configuration file where you have lots of configuration options. It's an advanced feature, this is where you would specify the correction factors. So in order for ETAP to take the orientation factors for your locations, for the Arc Flash location that is being labeled, is number one, you need to specify that at the bus location itself, like I did under the rating page. Step number two is to go into this ETAP s.ini. It's a text file. Scroll down to the following location right here. It's called apps variable, and this is where you would specify the user defined correction factor. As you could see here, you have 1, 2, 3, 4, 5 different correction factors, one for each one of these configurations, right? So you have your vertical conductors in a box, you have your vertical conductors in open air, and again, all of these are as per 1584, and then just below you have your vertical electrodes in cubic box terminating barrier, you have the horizontal in cubic box, and you have horizontal in open air. So VCBB, HCB, and HOA. And you're going to see, right, you're going to see those here as part of the text. And they're all separated by this little vertical flag. Now, when you first open the ETAP s.ini, you're going to find that all of these factors are the default. And by default, I mean as how they're published in the IEEE 1584. Okay? So you would have to go and change or modify those, right? As a guideline, when you open the ETAP Arc Flash help, right, the following correction factors limits are provided. So you could see here that for the first, second, third, the fourth configuration, right, that factor could be set anywhere from 0.7 to 0.85. Right, that is for horizontal conductors in a box, or horizontal open air. It would be 1.1 to 1.2. Okay. Now, one of the things that we need to make clear to everyone is the disclaimer, right? Any of these correction factors, because again, ETAP is just providing the tool to allow for this such modeling. So any correction factor that needs to be applied, you know, it should be applied with special engineering assumptions. So basically what I'm saying is use your own engineering judgment when selecting such factors. If you are not, and the reason why is that because these factors are outside of the scope of the current Arc Flash standards available as of today, 2015, there is really no guidelines on how to select these correction factors other than a few IEEE papers listed here. So the bullet points that you see right here are basically a few IEEE papers and white papers published on the subject on how to handle additional equipment configurations and in Arc Flash incident energy equations. So again, these correction factors are to be used, and your own engineering judgment should be applied to this. ETAP is simply just providing the tool. As an added benefit, in order for you to show these correction factors, ETAP allows the ability to display them right on the text report. This is part of the Arc Flash Result Analyzer. This is enabled by default. And I'm going to go ahead and show this to everyone. How these correction factors are automatically applied on the report. So when you open the Arc Flash Result Analyzer and you're getting ready to customize this report, turn it into the customer, one of the things you'll see on the bottom left corner is the results field. Under results, one of the items is called Arc Current Correction Factors. That is always checked by default, which means that there is a column right here called the Arc Current Correction Factor And by default, that's always going to be set to 1. Those are the default equation factors. If you were to change that to 1.1, 1.11, any of the other, anything within that range that I showed you, or that you can get from those white papers, it would automatically be shown right here. So you could kind of use that as a way to show, right, to disclose that you are in fact using different correction factors for your orientation. So again, that is on the Arc Flash Result Analyzer on the bottom, right next to results. Okay. This kind of wraps up the items that I wanted to go over today for ETAP 14 Arc Flash. At this point, what we're going to do is we're going to go ahead and take your questions. If you have any questions, please make sure to put them under the questions / comments chat, and I'll go ahead and stop the broadcasting of my screen, but we'll stay behind for the next 20 minutes to answer any questions you may have. You can also email your questions to sales@etap.com. Just make sure you put on the subject line Arc Flash webinar, so we may be able to get back to you promptly. Thank you and have a good day. Bye-bye.